Hi, Norbert here, energy engineer, and showing in the following video of series number 34 how I built my system to live on 12 volt of a battery instead of on the public grid. The main idea here is to obtain a reliable supply from a non-reliable grid. There are about 750 million people without any access to the grid, and they can use this system as a basis for off-grid life. But return to the people which are on the grid but it's unreliable. How many more people are those? Maybe a billion? Okay, for those people I have here a simple low voltage system which costs in Europe $250 and gives you continuous energy supply for at least a limited number of essential household functions. And if you look until the end of this video, then you will also see why I failed to use a battery for electric welding. But its main function, to bridge one blackout after the other, is no problem at all. So this video is in the first place for the people with a connection to the grid, but with too many blackouts to live at peace. And for the people without the grid, I have this advice to make this video relevant also for them. Adding one or more energy sources to this basic system will upgrade it to an off-grid system, useful for the before mentioned 750 million people with no grid connection. That means that this video is useful for about 2 billion people, if you count also the people in the richer countries which are worried about an unreliable grid system. I am sorry that I could not find time in this video to show also the household appliances as promised. The building of the system alone is already enough to fill more than 10 minutes. In addition, I need also time to translate and correct the subtitles in 7 languages in order to increase the reach of this video, including many viewers in developing countries that talk, for example, French and Spanish, in addition to English. Together with my research and experiments, that is really becoming a full-time job with 2 videos a week. So I hope that you can find a few seconds to subscribe with notification so that you know when I have a new video. So I will now connect the battery according to the diagram. But first let's treat some basic concepts. I've been charging this battery with a laboratory power supply with constant current and constant voltage, the 2 phases, for a good battery charge, until 14.4 volts, and with the current decreasing under 3% of this 100 ampere capacity battery, so 3 amperes. And here it is even only 1 ampere, so that's 1% of the capacity value. And you see also that the current doesn't change anymore, so that's also a reason to disconnect the charger. Take care of the wires, because for 4 ampere you should at least have 1 square millimeter of copper. These wires became warm, and more importantly the cool box was not working well. And even with this normal wiring components for 230 volts, it's 4 ampere, and you see already that it is warm. It's lukewarm. So the current of 4 amperes is indeed a little bit too much for this connection. Please remember, for each 4 amperes take 1 square meter of section of copper wire. More is even better, because if you are in a warm country and inside can easily get 40 or 50 degrees, then a little bit of power, it will really heat up the installation too much. So take for each 2 or 3 amperes 1 square millimeter of cross section. So here are the connections. Here's the connection box of the solar controller. We will now connect these big thick wires. which go to the battery. These are the two wires to the battery. The plus pole, this the plus pole, and you see how I connected this terminal to the wire. And now I have this connection for the plus pole of the battery. So this goes on the battery, and here are several connections. So I will fasten this one, the plus pole, and the plus pole goes then, I connected it already. The other end has this automatic fuse which you saw already last week. And now you see that I added 150 fuse here because it's double security. And this 150 fuse will not blow up if this fuse of 100 ampere works well. This is the plus pole of the battery, and you saw that pole which I connect to the battery. And then I put the connection of the solar charger I will put on this side, on the AUX of this fuse. So the plus pole of the charge controller is connected to the fuse and not directly to the battery. But the minus pole can be connected to the battery directly. So we have this other connection point, and you see there are several connection points for the battery. So let's now connect the negative terminal of the charge controller to the battery terminal. So okay, there we are. Now you see there are several places here on the terminal of the battery, also here. So I can put there also other uses, but for the plus pole I will not use these ones because I want to have the safety of the fuse. So that means I will connect everything to this side of the fuse. And why isn't this working? That's because I have to switch this on. I have to activate this. And there we are. I see 12.7 volt. And now when I push here, it's off again. Alright, so what I wanted still to say is if I'm charging, then I can directly put it here. You don't need a fuse, of course. So for example, if I'm talking about this device, this laboratory power supply, which is intelligent enough to charge a battery with a constant current and constant voltage, then you will see I put it now on 14.4. Okay, there we are. And then I can take these terminals and I can put it directly on a battery. And then it is good to have these terminals, these extra terminals. This is already on a final voltage. And you see also the green light of constant voltage is lit. So that means we are in the second phase of the charge, no constant current but constant voltage. And what do you see here on the charge controller? You see 14.3, so they are more or less, they agree. Now, if this charger would be not so intelligent and have not this procedure that you can fix it on a final voltage, then you could still use the intelligence of the solar charge controller. And then we take this out and then we put here the voltage of our solar panel. Let's put it on 19 volts. It's okay. Here we have a solar panel. These are the connections of the solar panel because there's 19 volts. And now we put it on the input connections of this solar controller. And there we are. It's now charging. In the constant current phase. Indeed, we didn't arrive yet at 14.4 volt. We increase the current. So let's say there was a cloud before the sun, and that is going away. And now it's starting to flash. And what does it mean? It means that we are in the constant voltage mode, that the charge controller starts to control and to limit the voltage. Okay, so you see here that you can use any charger also on this input of the solar panel, and it doesn't have to be a solar panel. This is a permanent magnet generator. I want to put it on a fitness bike. And then if you take these outputs of which are alternate current and you rectify them and you do some processing with the current, which is easy, then you can put that on the input of this charger, and then you have another source of current.
So what can I do after seeing this video?
Well, you can start to look for a battery of at least 60 ampere hours. But if you can afford 100 ampere hours like mine, then it is better. And even if a car battery becomes too weak to be able to start a car engine vigorously, then it is still not too old to help you and start this system, so that you can at least gain experience. And if you really want a good battery that can be deeper discharge, so contain more energy, then the lithium battery is a good choice, and it will last much longer. Therefore it will be cheaper on the long run. But it's still important that you have a good measuring device, that you measure the voltage, that if during connection of the grid charger, during charging, the battery voltage will not go beyond 14.4 volt. Some batteries can even be charged up to 14.7 volt. So read the instructions of the battery or look to internet resources, because there are different types of lead batteries. Overcharging the battery is not good at all. Okay, for the persistent watcher, here's the failed welding experiment with direct current from the battery. I hope you liked this video, and if you belong to the 2 billion people which I mentioned, you will surely want to make this affordable but essential step for reliable power at your home. Please like and share the video, subscribe to the channel with a notification. Come back on Wednesday and I will show you the low voltage appliances which I found, which can help you to have the most essential functions at your home, also in case of a blackout. Prepare for a surprise because you can do many things on 12 volt. I wish you good energy.